Hey everybody, Trevor here again. For this week's blog post, we got a little technical. Well, I should say a little technical. We got really technical. What I'm going to show you today is all the different stuff that goes into generating a single query in Trevor with data. And then I'm going to show you how you can actually recreate that same query by hand in BigQuery to show you why you wouldn't want to do this yourself or even use AI to do it. So let's dive in. Here I've got a pretty basic report. You can see I've got marketing channels with unique users and sessions and revenue. I've even got a top level segment applied of purchasers, person level segment. So let me go ahead and open up the network tab here. And you'll note that's kind of small, but you'll notice that when I refresh this report, it fires off an API call called execute table report. And in there, it just has a few simple parameters like a date range, dimensions, metrics that I've included, and the segments that I've included. The thing is, under the hood, there's a lot happening here. Our APIs that we've created basically have to take this basic, simple request and turn it into this complicated SQL that it has to use to actually generate these results. So let's dive into what that actually looks like if we were to do it in BigQuery by hand. I've got the query saved here in BigQuery. And you can see here, I've got this example report already pulled up in this API call that we just made. And I want to walk through with you all the SQL steps you would have to take to actually recreate this report. So the first thing you got to do is actually do the identity map resolution. I've got my cascading IDs going. I can see, the lookup from device to a customer ID. Then I'm going to do this crazy union of all of my different event data sources into a single event stream. So you can see I've got my store purchases, my call center data, I've got my device data, my web analytics data here, and I've got my mobile data here. So this is going to union all of these together to create that single data group-like thing that we did previously so I can see the holistic thing. Next, I'm going to sessionize the data. And you can see that uses a lag function. And it uses, I'm doing this within the time zone that I live in, which is mountain time. So you can kind of see we have to first do a time zone shift and then apply the sessionization logic like this. So you can see with a 30-minute timeout, this is what that SQL would look like. After we've sessionized the data, we also have to do further timestamp conversions because I don't want to see the data in UTC. I want to see the data based on the time zone I live in. Next, we're going to compute the dimensions and metrics. You can see I've got some basic marketing channel rules here just to show you everything that goes into it. I've got a few metrics that are being defined. So that comes next. Then we're going to evaluate all the segment conditions with the window functions applied. So this is a person level segment. So I have to do this over a partition of person ID. And then the final aggregation happens in this last step where I can now kind of sum all of this up. I just want to take a second and pause here to show you how complicated it is to actually create this type of query. You can see all the different steps that are happening. This isn't something you want to try and manage yourself. And you also wouldn't want AI to do this. Think of the number of tokens you would try and burn through trying to edit and create this. And one small problem, and whether that's something you typed or something the AI did, it kind of just silently fails and you get wrong numbers and you didn't even know it. That's why we built all of these rich APIs that handle this complexity under the hood and abstract it away so that you don't have to worry about it. And when we eventually put AI on top of what we're doing here with Trevor with data, the AI can work with the data much more easily and not blow through all of these tokens and stuff. So let's actually run this query and see how it does. Okay, awesome. The query finished. Now let's take a look. So looking at the results, you can see that the numbers match. Let's take a look, 1070458. If I head back over to Trevor with data, you can see the numbers match exactly. So we were able to get this to replicate precisely down to the penny. So that's really cool, actually. Let's see, we had 443 on direct and 116 on paid search. Boom, you can see exactly the same. Awesome. So you can definitely get the same results here. But let's look at the execution details. Here, you can see that the elapsed time for this query was 2 seconds. Not bad. And that's actually comparable to what we saw in the UI with Trevor with data itself. But where things get a little crazy is in the slot time consumed. You can see BigQuery is using a lot of compute parallelization in order to get that sort of performance. So in this case, we probably had about 30 different nodes all working on this report. This slot time is the actual CPU used across all of those nodes. So the speed that you're getting is because BigQuery is throwing a lot of resources at it. Now, ignoring the complexity of managing such a large SQL system, it's important to understand that general purpose warehouses are not really designed for this type of query. So this 60-second query, slot time query, adds up fast when you have a lot of people consuming different flavors of a report, different slices of it, and it gets really expensive really fast. So now let me show you how that compares to what we've set up in ClickHouse. So this is ClickHouse, and if I look at the same query that I created here, I'm actually using the smallest instance of ClickHouse. So it's just a single node that's running. And when I run that same query in ClickHouse, again, the user doesn't see any of this complexity. It's all happening programmatically behind the scenes when we call that API. You can see that the amount of time it took to run that query was actually half a second. So in the UI, a lot of the time that you see is not actually the query running, it's actually some of the APIs kind of assembling things. But the memory usage is about the same, and it only used a single node. So it is doing this query much faster and with way less computing resources. That doesn't matter that much when you have a small example data set and a single person running it. But when you scale that up to a large amount of data with a lot of people consuming it, that starts to matter a lot. And that's really the strength of having a dedicated journey analytics tool and why why this industry exists. So for building your own and journey tool, you got to be really careful about the query engine that you select. And ClickHouse has been great for that. So anyway, hopefully this is helpful, and good luck out there. I wish you all the best.